So we got ourselves an equation. Let's play. So the first thing, we can answer we don't even really need our TIs if we've got that screen up there. The thing is that I created that in Excel, and unless you guys know how to do it in Excel, which you will by your last exam, yay. But right now you might not have that in your toolbox yet, and that's okay. I don't expect you to. But that's why I wanted you to have it in your machines, because I wanted you to have that ready to be able to use in front of you. So we did this, interpret the slope. Now when I say interpret the slope, I don't mean tell me the slope. Sometimes students will say, oh, the slope, interpret, it's 1.05. That's what the slope is. But what does it mean? What does that mean, 1.05? Especially the in context part. 1.05, what? This is that dimensional part. What is 1.05? Yes, it's a great number, it's a lovely number. 1.05, Trudy, what?
About 1 million people or so a year become uninsured.
Perfectly said!
Since 1990.
Oh good, you can even get more, very nice Amy, you can even get more restrictive and say from 1990, you can even get more, from 1992 to 2000, we picked up about 1 million more uninsured people per year. That's totally fine. The big thing I'm looking for is the people, millions of people per year. I need to know, it is a slope. It's a change in y over a change in x. So it's a change in millions of people over a change in years. That's what the context part is. That's what the context part is. The 1.05 is important, but telling me what that means is probably more important. Knowing that it's 1.05, fantastic. But knowing the magnitude of that. Amy, go ahead.
So, just to understand what you expect, like if this were a quiz.
Yes.
Because I did it both ways. I did it like a diagram. I put the change in millions
good
of
for
people
you.
over the change in years. But then I also put every year since 1990, verbal. And so
you drew a picture and then you made it verbal.
I did.
The verbal is what I'm looking for.
Okay.
I want you, see here's the thing. What I've learned is if you can say it to someone, they'll understand it better. Not everybody, sometimes math shuts people down. If you try to explain something with mathematics to people, sometimes they get shut down, but if you talk through the mathematics with them, a lot of times that breaks down barriers. Sometimes you have to use mathematics, you just have to, it's like part of our life. But if you can talk through and tell them why or what or how. So that's why I like the verbal. So that's what the interpretation means. Beautiful. Beautiful. We also nailed this one. In 1995, how many uninsured Americans were there-ish? And we had like 2 or 3 different ways of doing this in class last time. Go ahead, Ashley.
38 million.
Yeah. How did you do it?
You find X, you find 5, or choose.
Go ahead, go ahead.
Which one are we doing?
1995, we're just doing a second one right here.
1990. So you subtract and you get 5, so then you find.
How'd you get 5 again? Tell me. It says 1995.
95 minus 1990.
It's years since 1990, which that means X would be 5. And then what did you do?
And then you find 5 on X and
Good.
match it up.
Good. Are you using this graph here, Ashley? That's great. And that's what's nice about having this graph in front of you. You can just go, okay, 2, 4, 6, 5 must be here. Ha! Oh. So it looks like it's a little bit past 38 million. So it actually said around 38 million. Perfectly within the ballpark. Suppose you needed more precision for whatever reason. Can we use technology to get more precision? And we did learn this. I forget who brought it up on Wednesday. But you can use this thing called the table on your machines. Let's revisit that to make sure we know how, okay? Let's revisit that to make sure we know how. Hopefully that comes up. Yes! Okay, so I'll turn mine on. So there's my graph, just like you guys have. But if you look at the graph button, it's actually got above it, there's a little blue, mine is blue, it might be yellow on yours, depending on your model. See how it says table right there? Everybody press your second function button. Now mine's blue, it's right here, right there. So press that one first, and then press the graph button. And you get to what's called the table menu. And I still got mine in there from where we did it on Wednesday. At this point, you can just type in whatever X value you want, and it'll spit out the Y value for you. So if you type in 5, and press enter, it's going to pop out 38.35. So that was a little bit extra. We had this idea that it was a little bit more than 38 million. We picked up about 1/3 of a million more people, about 350,000 more people-ish. It's all, exactly. It's all approximate. And we'll talk more about that as we go through today, because one of the biggest parts of today I want to finish with is the idea of the uncertainty in our answers. We'll get to that towards the end. So that's if you needed more precision for whatever reason. Please! It's not letting you do it, is it?
No.
Okay, if anybody's sitting there slamming on 5 and it's like, what the hell, you stupid machine? You have to make sure your machine is ready to let you do that. Is anybody having that problem? You're trying to type 5 and nothing's going in? You just got to, well, here's a fix for it. Press the second function button again.
Okay.
Now press the window button, which is right here. And you see where it says,
Yeah.
make sure that's on ask. That's for, what does that stand for? Is this starting to sound, you're starting to get deja vu about my bad jokes? Yes, yes. So make sure that's on ask. Now go to second graph and you should have a blank screen. You can type anything you want in for X and it'll pop out Y. Now, you might wonder, why didn't you, well actually I'll come back to that. We'll come back to that. We'll answer the next questions. Cool? That was a success? All right. Beautiful. Let me switch back. Let's get back to our questions. Find X. This is a pure algebra question. Find X so that Y equals 40. Pure algebra question. Do it any way you can.